I'm going to finish up section 2.4. This portion talks about the relationship between parallel lines, perpendicular lines. Parallel lines in the same plane that never intersect. Lots of different ways of identifying parallel lines. Sometimes you see a definition that says two lines in which the distance between them is always constant or never changes. Perpendicular lines are lines in the same plane that intersect to form right angles. Okay. Hopefully those two things are topics that we've discussed heavily in a geometry course. Parallel lines, the reason that they never intersect or that the distance between them is always constant is because they share the same slope. So the way that one line's rise over run compares to another line's rise over run is that they change in the same manner. Okay, so this red line here, for instance, rises up 1 and over 2. So as it's changing, its average rate of change is the same here in this blue one of up 1 over 2. So because those average rates of change do not deviate, these lines will never gain will never converge to one another. Okay, the gap between them will never minimize. Therefore, these lines will be parallel, and it's simply because their slopes are the same. Okay, it says all horizontal lines are parallel, and all vertical lines are parallel. Vertical lines obviously have no slope, okay, or a slope that does not exist. Horizontal lines have a zero slope, okay. But non-vertical lines are parallel if and only if they have the same slope, okay. So that right there, I want to use the phrase if and only if, because it allows me to say they're parallel if they have the same slope, but it also allows me to say if they have the same slope, they're parallel. It's actually a statement that we can use in both directions. So just kind of jumping in here to some examples right away. We're going to use in combination with what we've already talked about in the last couple sections with this new idea about parallel and same slope to create some equations. So this first example says a line passes through -3, -1, and is parallel to the graph y equals 2x plus 3. What equation represents the line in slope-intercept form? What is the equation in standard form? Okay, so it passes through -3, -1. Now if I graphed 2x plus 3, let me just graph this real quick on Desmos for us.
They were so stress-free, the whole process was amazing, and I would definitely recommend them.
Okay, so that's the line y equals 2x plus 3. And if I look at it, it does not go through the point -3, -1. It does not go through that blue point. So what we're trying to do is we're trying to find what is the line, what is the equation of the line that would be parallel here and pass through that point -3, -1. Okay. Well, if it's going to be parallel to this red line, and this red line has a slope of 2, then this line is going to have a slope of 2 as well. So I'm going to keep that in mind and come back to these notes. Alright, so if we know that our new line is going to have a slope of 2, we should be able to say our new line will fit this formula, and we know the slope has to be 2, has to be the same as the line that's being parallel to, and it has to go through this point right here now. So y1 is negative 1, so I'll say y minus negative 1 equals mx minus negative 3. Now remember, this form is point slope form. Okay. Now it wants it in slope-intercept form, or y equals mx plus b form. So we're going to rewrite this as y plus 1 equals 2, x plus 6.
So, Your Honor, I'm concerned that what President Trump wants here.
Distribute my 2.
That he's trying to rush this nomination.
And now, oh, this wasn't a 6, this was a 3, sorry.
Opposed in his favor in the event of a disputed
3, making this 6. Got ahead of myself a little bit. Subtract 1 from both sides, I get 2x plus 5. Okay, that is slope intercept form. So if we graph that, we can see, so we wanted a point, or I wanted a line that goes through there and was parallel to the red one, so we think it was y equals 2x plus 5. And we see that that green line indeed goes through the point that we were asked for it to go through, negative 3, negative 1, and it appears to have the same slope as the red one. Same, we call that the average rate of change, so the same rise over run. And obviously we can see that the way we typed it in with the coefficient from our x as well. Now it asks us to put this in standard form as well, okay? So standard form would be that the x and y are on the same side. So I'm just going to move this 2x over. So we write this as negative 2x plus 1y equals 5. Okay, now I'm okay with that. I'm not sure what Web or Math Excel will do, because a lot of times there's texts that say that they want this term here to be positive. So if they want that to be positive, all we got to do is multiply everything by negative. So it becomes 2x minus y equals negative 5. And that is called standard form. Standard form, remember yesterday was ax plus by equals c. Slope-intercept form was y equals mx plus b. And this here, that was your point slope formula. Now, to check to see if this is right, this is the nice thing about Desmos, is I can actually type in 2x minus y equals negative 5. And you see that it does graph the same green line. Okay, so that is an equivalent. These two things are equivalent to one another. Let's jump down here to this next idea. This next concept is dealing with perpendicular lines. Okay, perpendicular lines are lines that intersect to form right angles. Okay, it says each vertical line is perpendicular to each horizontal line. So if you've ever dealing with a vertical and horizontal line, they're always perpendicular. Okay, and that is one situation in which it's the way we check perpendicularity is through the multiplication of slopes. But if I do it with vertical lines and horizontal lines, remember vertical lines have a slope that does not exist, so I can't do multiplication with that slope. But every other set of lines, says two non-vertical lines are perpendicular if, it should say if and only if again, the product of their slopes is negative 1. So if I know two lines are perpendicular, their slopes are going to multiply together to give me negative 1. And if I have two lines whose slopes multiply together to give me negative 1, then I know that they are perpendicular. So this again is a two-way street in regards to how we apply that principle. So here we've got two equations being graphed. Y equals negative 1/2 or sorry, negative 2x plus 1 is this blue line, and the red one is y equals 0.5x minus 1, or 1/2 x minus 1. So if I look at the slopes of these two lines, okay, and I take 1/2 times negative 2 over 1, so we get 1/2 times negative 2 over 1, that gives me negative 2. We multiply straight across the top, so we get negative 2 over positive 2, and that reduces to negative 1. Got a slope of negative 1, and that tells me that my two lines then have to be perpendicular. Okay. Now the one thing to talk about is we also use the kind of the visual approach or the visual recognition of whether things are perpendicular, lines are perpendicular, based on how this number here relates definition-wise to that number. Okay, and if you think about it, all they are is a flipped fraction. So a flipped fraction, we talked about those as reciprocals. Okay, and if you remember back to the properties we talked about in chapter 1, we talked about multiplicative inverses being two numbers that multiply together give me 1. Well, now we're getting negative 1 as we take two things and multiply them together. Another word for multiplicative inverses we talked about back in chapter 1 was reciprocals. Okay, so these are not purely reciprocals. Okay, they are opposite signed reciprocals because one of them is positive and one of them is negative, so those are opposite signs. Okay, so we have two tests that we can use to determine if two lines are perpendicular or not. Visually, and under visual inspection of the slopes, we can ask, are they opposite signed reciprocals? Okay, that's the one. That's usually the easiest one. Okay, but it's at times maybe one that's almost impossible sometimes based on the types of coefficients we're given to recognize. And the other one is that the slopes, what's it, product of slopes equals negative 1. Okay, this one is out. That's an algebraic rule, and that one is kind of fail-safe. You can't mess that up. Okay, people tend to mess this one up. Just some examples here of reciprocals, opposite signed reciprocals. If I have 2/3, that's reciprocal is 3/2. The opposite sign would be negative 3/2 because this was positive. Here this is negative 4/5, so the reciprocal would be 5/4. And because this was negative, this would be positive. Okay, flip these, I get 11/7. This was negative, so this would be positive. This is 3/1, so its reciprocal would be 1/3, and it's got to be negative, because that one was positive. This one is 1/9. This would be -9. And what happens if you pay attention to how we do this, 2 times 3 is 6, 3 times 2 is 6, we get 6/6. Positive times a negative is a negative, so we get -6/6, which is -1. This gives me -20/20, -77/77, -3/3, and -9/9. All of those reduce to -1 when I multiply them together. Okay. One thing I like to pay attention to is, what if they give me an equation that says like y equals let's say 4x plus 3, and another one that says y equals -0.25 x plus 7, something like that. And the question is, well, are these perpendicular or not? Well, because this one is written as an integer, okay? This one is written in decimal form. They're not the same format, so it's hard to tell. It's impossible in that format to tell whether they are reciprocals or not. They both have to be written as rational numbers and not in decimal form to determine if they're opposite sign reciprocals. Okay, so in this case, it might make more sense to take the 4, multiply it by the 0.25, and see that I get negative 1. This is a negative 0.25. And notice I get a negative 1, and that then tells me, yes, these two were perpendicular. Okay. From geometry, you should know that that upside down T, capital T, is the symbol for perpendicular. So let's do this example here. Says find the equation of the line that passes through 2, 5 and is perpendicular to negative 1/2 x minus 4. So again, all I want to do, come here and we will type in y equals negative 1/2 x plus 4. Just want to make sure that that's the correct equation. Negative 1/2 x minus 4. Okay, so we want, there's an infinite number of lines that are perpendicular to this. Okay, there's a lot of lines that kind of go this direction, maybe there, or maybe down here, that would be perpendicular. Okay, but there is one and only one that passes through the point 2,5. Okay, so the point 2,5 is up here. Okay, I want to create the line that is perpendicular to this. So when I create this line, I know 2,5 has to be on it. So that's going to be my x1, y1 when I write my equation. Okay. Now it has to be perpendicular to this line. Well, if it's going to be perpendicular to this line, and this line has a slope of negative 1/2, then the line that is going to be perpendicular to that should have the opposite sign reciprocal of negative 1/2. So I'm going to keep track of this information over here. Right now, I'm going to call this the given line right here. So y equals negative 1/2 x minus 4. That is the given line. It's the one I'm provided with. Okay, and it has a slope of negative 1/2. Okay, then that means the slope of the line that we're going to try to create perpendicular. So I usually write m, and then as a subscript, this little perpendicular sign, just to tell myself that that's the slope that I'm going to use to write my equation of the perpendicular line. So if the given line was negative 1/2, the slope of any line perpendicular to it should be the opposite sign reciprocal. So it's going to be 2 over 1, and it's going to be positive. Those two slopes multiply together give me negative 1. So now I've got my slope that I have to use, and I have my 2, 5 that I know I have to go through. So here's x1 and y1, and here's m to fulfill the variable parts of that formula. Okay, so I'm going to plug in y1 as negative, in this case 5, so y minus 5. Slope is 2, x minus x1, which is 2. So I'll have y minus 5 is equal to 2x minus 4, and then y equals 2x. I'll add 5 to both sides, so I get plus 1. Okay. If I wanted to, so this here, remember this was point slope. This here is called slope intercept. Let's go ahead and put this in standard form. So I'll move the 2x over, and then let's just make that 2x positive. So either one of these, I'm okay with you calling standard form. Okay, all of those lines should generate the same line. So let's just go ahead and go over to Desmos and see if that happens. So if I graph, I'll type in y minus 5 equals 2 times x minus 2. So it's that top one right here. Okay. It gives me this green line. You see it gives me this green line, and it goes to the point 2, 5. Okay. Goes to the point 2, 5. Now the one thing about this program that I can't tell, I can't have this thing ask me or give me degree measurements. But I'm going to tell you that is a right angle there. I could also type in, like I said, y equals 2x plus 1. Gives me the same line. Or we could have gone negative, so let's go positive 2x plus, that would be minus y equals negative 1. Gives you that black line. So you see all of these lines are the same thing. Okay, so these are all that one, and that one. Equivalent versions of the same line. No way that deleted. So the rest of your homework should, over the section 2.4, should now be able to be completed using these concepts. Again, if you have any questions, please don't hesitate to reach out and ask them.